Good morning, students. Today is Tuesday, October 13th, taking you through a virtual lesson. This will be for A-Day students on Tuesday, October 13th, and then B-Day students for Thursday, October 15th. Hope everybody's doing well. Taking you through a virtual lesson. This lesson that I'm taking you through today will actually be a 2-day lesson. So don't feel as though it's something that you have to start and finish all in one sitting. Um, it is the assignment's titled Engineering Design Process, and going to take you through a slide presentation through the video here and kind of indicate to you what to do as you're watching the presentation. So I would recommend when you open the video up and you're listening to the video is that you also open the assignment as it's going along, just kind of how I'm doing that right now. Um, we've got the presentation here and then the note-taking sheet, okay? So I'm gonna go back to the presentation. Just a quick review. What are engineers and engineer design solutions to help solve practical problems? They're often trained in math, science, and technology, and all engineers use a systematic approach that's called the engineering design process to first identify a need and then find a way to solve the problem. Way back in August, we learned about the function of engineers, the different type of careers that engineers have, whether it's from medicine to uh, technology to just about anything. And engineers solve some of the most complex problems that we have in our society. What you do then is, as I go through the presentation, is go and fill in these blanks as I go through. Okay, so there's a couple of different ways you can do this assignment. I think the easiest way is to watch the video and then fill in the blanks as it goes along. Okay, whatever process you want to follow is completely up to you. Next slide here is the first step in the engineering design process is to identify the need or the problem. You don't want to waste time, money, or resources on a problem that doesn't need to be solved. Make sure that the problem you're trying to solve is real and find out if there are any constraints that you have to be aware of when you're working. So engineers either solve a problem or take something and make it easier for the consumer in order to do it. Um, Lots of different ways that they go about doing this. Step number 2 is research the problem. The more information you can gather before begin working, the better off you'll be. Find out if other solutions have already been tried. Talk to people, conduct a survey, use the internet to see what else is out there. Obviously, the internet's not the only resource when trying to find information. Engineers discuss, previous solutions with other engineers to figure out what's been done before so they don't make the same mistake again. Find out that when they made the mistake, maybe there was just one thing that they needed to tweak in order to make it better. Step number 3, develop possible or potential solutions. Brainstorm with other people to come up with many different solutions. Look to be creative. Think outside the box. You may want to come up with something that no one ever thought of before. Always remember to keep an open mind, okay? And the first idea isn't necessarily the best idea, okay? And it may be a really good idea, but maybe there's some changes that you need to make to it. So engineers definitely have to have an open mind. They have to look at complex issues, complex problems, and look at different ways of solving them. And keep everything on the table until it's been ruled out as not a possibility. Step number 4, select the best possible solutions. After considering all of your ideas, choose the one that best met the need or solved the problem. You may want to combine parts of different ideas to make up one best solution. Think about constraints that you might have to work with. These are factors that may limit or restrict your design, like limited time or resources. So You might have a solution. That solution may work, but then you start looking at the cost of that solution, and the solution may be just way too costly. So you look at ways of minimizing that particular cost. If you come up with a solution that nobody can afford, it's really not an effective solution. You may come up with a solution that is it fixes the problem, but it doesn't in a relatively dangerous way. Okay, you can't be putting people at risk of getting hurt in your particular idea. So you're looking for the best possible solutions in step 4 in the engineering design process. Step 5, construct a prototype. A prototype is a working model used to test your designs. Prototypes allow you to spot flaws in your design before you make your finished product. Consider building your prototype on a smaller scale. Well, why would you do that? Well, it's quicker and it's easier. It's cheaper, it uses less materials, and it's easier to redesign and make changes. Automotive manufacturers do this all the time. They take a look at an auto that they want to develop. They basically hand make it. I mean, obviously with the use of machines, but they develop it and they see if it's actually an effective design, something that they can mass produce and sell. So they make what's called a prototype. So literally automotive manufacturers like GM, Ford, Mercedes, or whatever, have literally warehouses full of prototypes, cars that were never mass produced at a certain point, that they made, and they tested them out, see where the flaws were. Okay, and they wanted to mitigate as many flaws as possible, because when they went to mass produce these, they didn't want to continue to make the same mistake over and over again. So this is a pretty important piece to the engineering design process, is designing a prototype to see if it actually works on a small scale before you mass produce it on a very large scale. Test and evaluate the prototype. I guess I kind of skipped ahead here. Once your prototype is built, you want to find out if it works. Does it meet the need or solve the problem? Conduct tests to see if it functions as expected. Are there any flaws in the design? And what can you do to make it even better? Okay, so when you're looking at this piece, the testing is pretty important. Okay, again, you want to be very, very critical in your evaluation of the prototype, because the idea is if the prototype works, then you start making steps to make it for real. Okay, make it that it's actually usable by multiple people. Step number 7, communicate the solution. Share your solution with others, talk to people, publish your results, or present your design in front of an audience. This is where you're selling your solution. What can you do with your solution? And this is an important piece, because you can come up with a great solution, but if that solution is not something that anybody knows about, kind of defeats the purpose of coming up with the solution in the first place. And then the final step, the redesign. How well did your solution work? Did you find any flaws in your design? If so, make the adjustments as necessary. If you had more time, money, resources, what would you do differently to make your design even better? Did your design meet the need or solve the problem? Any cell phone that's ever been developed, there's always different versions. There's versions, the 1.0 is different than the 2.0, and the 2.0 is different than the 3.0, and so on and so forth. Engineers look at the original design and look at tweaks of making it better, making it faster, making it less expensive, making it more effective. And this is what engineers do during the redesign process. So they'll launch the 1.0 out with keeping in mind that they will go to work on the 2.0 and launch that a year or two later, sort of like the sequel. So anyway, that is the engineer design process. I've gone through all 8 steps in this video. You can pause, fast forward, rewind as many times as you need to in order to get all of your answers. Again, this is your note-taking sheet. So as you watch the video, fill in the blanks. Understand, as you fill in these blanks, this line will move. So you may just want to delete the line and then put the term in there. If you have any questions, please let me know. Again, this assignment won't be due until next week. So for my A-Day group, it'll be a week from today, Tuesday. And then for my B-Day group, it'll be due a week from Thursday. So, and again, this will not be on the first quarter, this will be on the second quarter. We're continuing to work on our Rube Goldberg machines in class, continue to bring in those materials that you want to for your machines. I'll continue to bring in odds and ends thing, but continue to work and manage your class time as best you can. Thank you and have a great day.